Hello friends, our today's question is find the minimum and maximum number of nodes between critical points. Okay, so what is basically given in this question is what are critical points. So critical point in a linked list is defined as either a local maxima or local minima. Okay, so critical point in linked list here they are defining as local maxima or a local minima. Okay, so our node now what is local maxima? Local maxima is a current node which has strictly greater value than previous node and next node. Okay, and then local minima is what the current node which has strictly smaller value than the previous node and the next node. Okay, so these two are these are the definition given for local maxima and minima, and these are called as critical points. Okay, so one thing also is given there, local maxima and local minima exist if both previous and next node are present for that current node. Okay, so that will be only considered in the for local maxima and local minima. Okay, so what they are asking from us is, given a linked list header we have to return an array of two length, okay, containing minimum distance and maximum distance. Okay, where minimum distance is the minimum distance between any two distinct critical point and maximum distance is the maximum distance between any two critical points. Okay, otherwise you have to return -1. Okay, so what is given in this question? Okay, so what we are having a linked list which will have a where we have to find the critical points, and to those critical points we have to like these are the critical points. First of all, let's see, like, okay, what is the critical point? When a current node is either greater than from its previous node and next node, or either the current node is smaller than, strictly smaller than its previous and current node. So here what critical points we can find? Five we will not consider because it is strictly given that a node can only be local maximum minima if exists both previous and next node. Okay, so if here previous node is not present and here next node is not present, so we will not consider them in the race of critical points. Okay, so 3 is not a critical point because it is greater than the next node but it is smaller than the previous node. Okay, so we will check for 1. So 1 is a critical node because it is smaller than the previous and it is smaller than the next node, so we can say this is the critical point. So 1, this is the critical point. Okay, 1 we can say. Then 2 is not a critical point because it is greater than the previous but smaller than the next one. Okay, then we have 5. So 5 is greater than previous and next, so we can say this is a critical point. Okay, and then 1 is smaller than previous one and next one, so we can say 1 is also a critical point. Okay, and 2 we will not consider because we are not having any node after that. So what we have concluded that, like, if we have given them the index, so 1 2 3 4 5 6 and 7, so at what places we are able to find critical points? At third position, okay, at fifth position, and at sixth position. Now this is the question, this is the half part of the question. Now what actually they are asking from us is, we have to return a array where we will return two values, minimum distance and maximum distance. So we know that we are having critical point at these places, so we have to return the minimum distance between any two critical point and maximum distance any two critical point. So what we can see here is, like, the minimum distance between any two critical point, minimum distance between any two critical point is 1. Okay, and the maximum distance between any two critical point is 1 1 2. Okay, 1 2 and 3. Okay, so 3. So this we have to return the minimum and the maximum distance between any two critical points. So this is a this they are expecting from us. So in this case, like, I have taken this example. So what is the output here is 1 and 3. Okay, so the same we are getting here, 1 and 3. Okay, if in case in example 1 we can see, like, we will not consider this in this for critical point, and we will not consider this for critical point because this is not having its previous node and this is not having its next node. So in that case, if we are not having if there are fewer than two critical points, then we have to return -1 -1. Okay, so this is the problem which we have to solve. Okay, so now what solution approach which we can follow here is, Okay, so first of all, the main task is to find all the critical points. Okay, because we can divide our problem into two portion. First, getting all the critical point list of all the critical points. Okay, and once we get all list of all the critical points, then finding minimum difference and the maximum difference from a list is easy. Okay, so we can do it linearly. Okay, so to find the all the critical points, what we can do, we have to iterate this linked list. Okay, and conditions are simple. Whenever a node is greater than its previous or the next node, it is maximum critical point. And whenever a current node is smaller than its previous and next, then it is also critical point. Okay, so conditions are similar, but from where we have to start and how we will check, like currently we are here, so we have to check the value for this. We have to compare its value with this one and its value with this one. So like next we can go like yes, from current point to the next, and we can check its value. But to previous one, how we can check? So what we will do, we will have two pointer, one previous pointer and one current pointer. So let me have those two pointers. Now what we will have current pointer and we will have previous pointer. So current pointer will point to current point and previous will point to the previous of the current pointer. Okay, now what we can say, as we know that first one, last one and first one can never be the part of critical point. One thing for sure, because they don't have the previous and this don't have the next one. So this is for sure that these are not the part. So we have to just iterate between this and this. Okay, and so this will define our main looping condition, like from where we have to start up till at what point we will iterate. Okay, so like we are starting, so like critical point for current position, what we can have, we can start from here. Okay, current pointer we can start from here, so we can have this at current point. Okay, and previously we will keep previous to like node previous to current pointer. Okay, now up till what point we have to go? If we are going, if we are checking up current pointer is not equals to null. Okay, so in this case, if we are going to up till checking this, so in our loop condition, when we where we will go from, like this is the current pointer. So we are checking, we are comparing this its value from the next value. So what we do, current pointer next value. Okay, so if we are going up till current is we are looping up till until current pointer is not becoming null. In that case, if we are at this point, so current pointer is not null. Okay, so it will fail in this condition, it will give us the error. Okay, because current is not null, but current next is null, and we will be referring we will be referring a value which is not present. Okay, so it will give exception. So what condition or a loop, what till where we will loop? when current when current pointer next is not null. Okay, so up till this point we will iterate. Okay, so now what we can do, so current pointer is this, so we will check we will check with the previous one whether it is greater than the previous one, or it is smaller than we will check either it is a local maxima or local minima. So it is not a local maxima, local minima, so current pointer will move to next one and this will become previous pointer. Okay, now what we will check, again we will check whether it is a local maximum, local minima. So it is a local minima. So whenever we will get a local maxima or local minima, we will add this value, like we have indexed them 1 2 3 4 5 6 and 7. Okay, so we will add this value to our array. Okay, so we will add 3. Okay, now current pointer will be incremented and previous pointer will be again incremented. Previous will be pointing to current and current will be moving to one step forward. So current, now we will again check whether it is a local maximum or local minimum. No, it is neither a local maximum or a local minimum. So again we will move these pointer. So current will be pointing here and previous will be pointing here. Now we will check whether it is a local maximum minima. So it is a local maxima, so we will add its value to our array. Okay, now current pointer will be moving here and previous will be pointing here. Okay, so now again we will check whether this is a local minima or maxima. So it is a local minima. Okay, so we will add its value to our array. Now current pointer will move here okay, and previous will move here. Now what we have checked, current null, current next is not equals to null, but here current next is equals to null, so here our loop will terminate. Okay, so what we have all the critical points from our linked list. Now what we can do, to find the maximum, it is straightforward. Okay, to subtract the last value and first value, so we will get our local maxima. Okay, but for minimum, what we will do, we will find the difference between the adjacent critical points. Okay, like 5 minus 3 it is 2, and 6 minus 5 it is 1, so we are getting minimum as 1. Okay, so why we are subtracting from adjacent one, because if we are getting any point between two critical points, then we can say, then it is obvious, like na, it will be greater than this one, because if we are having these two critical points, okay, these two critical, so obviously their difference will be always smaller than the difference between these two. Okay, so we will check with the adjacent critical points. Okay, so in this way we will get maximum and minimum, and we will return this as a array. Okay, so now let's quickly implement this. Okay, so what we can have, we can have a list node current. Okay, so what value it will have, as we are starting, as we will not consider this, and we are starting from here, so we can have head next it to this, so head next to this. Okay, then list node star previous is equals to head. Okay, previous will be pointing to the current previous. Okay, now for int, like we have to index this, we have to find the index. So like we are starting current, we are starting from here, so what we can here is, we can have a variable which we will start from 2, because it will indicate the current count will indicate where current pointer is pointing to. Okay, so we are starting it from 2, because first will be this and second will be this, and our current pointer is at second, so we have initialized its value with 2. Okay, now what we require, we require a vector ctr vector of int that will contain the what we can say is critical points, critical points, critical points. Okay, now okay, so this is we are done. So now we will loop through loop where current next is not equals to null pointer, and we have seen why we are doing, why we are making this condition as current next is not equals to null. Okay, so now we will check for local maxima or local minimum. So look for to check what we have current, to check for local minima, value must be smaller than current next values, value, and it should also be current value must also be smaller than previous key value. Okay, so if it is, then we can say this is a local minima, and we will add its value to critical point. Pushback count. Okay, else if we will check for local maxima. Okay, the same condition will be there with different operators. We will copy and we will paste it. So for current value is uh, greater than current next value, and current value is also greater than previous value. Okay, in that case we can say it is a local maxima, and again we will push the count value there. Okay, now after that, we know we will increment the current pointer, current next, and previous VIOS previous is equals to PREVIOS previous का next. Okay, then we will increment the value of count because we will point, the current will be pointing to next pointer. So this we have got all the critical points. Now to find int, okay, first of all we will check if because if we are having less than two critical points, then in that case we have to return -1 -1. So we will check if CRITICALPOINTS, okay, it's points. I have done spelling. It will be points. It will be points. Okay, critical points is are less than 2. Then what we will return? We will return -1 comma -1. Okay, and if it is not, then what we will do? Int minimum is equals to max int max and int let min value max value is equals to it will be CRITICALPOINTS points back minus CRITICALPOINTS points front front. Okay, so it will be maximum, as we have seen, like we are having critical points, so maximum will always be the because it will be always in sorted, like we are getting 3 5 6, so it will always be in sorted because we are iterating, or we are going to certain node, node by node, because to from if we are to this node, we are coming it from previous node, so it will always be in increasing order. Okay, so 3 5 6, so maximum will be always the last minus first one. Okay, so that's the same thing we have written. So for minimum, what we will do, once we will do for int I is equals to 1, I is less than CRITICALPOINTS points dot size and I plus plus. Okay, so what we will have, min value value is equals to min value comma CRITICALPOINTS points of I minus CRITICAL critical POINTS points of I minus 1. Okay, so this we have got our minimum. We will return our minimum and maximum. Min val, min val comma max val. Okay, now let's run this. I hope I have not made any syntax mistake. I have critical points dot size. Okay, let's run this. So it is accepted. Now let's submit. So it is accepted successfully. Now to the space complexity and time complexity, as we are using extra space to store critical points, so we can say that yes, the space complexity is capital O of n, and we are iterating this linked list one time. Okay, so we can say that its time complexity will be also capital O of n. Okay, where n is the number of nodes. Okay, so thank you for watching.